Okay, finally. So I worked on something on an idea that was suggested to me by James and Haley, and that it's related to their work. And I call it Argo Explorer, and it is about those floating probes. There are almost 4,000 of them floating around in the oceans, following the currents and taking measurements. They are fully autonomous, and they dive down to 1,000 or 2,000 meters and take measurements of salinity, pressure, temperature, and dissolved oxygen in the water. And then they come up again and send acquired data to a satellite, and then they go down again and repeat this cycle over and over again for years, as far as I understood. And I worked on a little web application that you can use to view this Argo data stored in netcdf files. And okay, here's again a slide that shows what I just explained, so I can skip it. And okay, I'll also set this. My presentation is going to be short, I guess. So this is a screenshot of my application. I will also show it in a live demonstration. On the left, you see a map that shows the locations of the positions where the probes came up and sent data to the satellite. And on the right, you see a plot of one such profile. Not one profile, but all the profiles that you can see. So the x-axis represents the profiles. Each column is one of the dots on the map, and the y-axis is the depth of the probe. And yeah, it's better shown in the live demo, I guess. And this is the system architecture. Actually, the project consists of two parts. And the left one, the Argo server, is sort of independent from the right one, because all it does is to provide access to an Argo netcdf file over a web client, a REST interface. And you can query data from the netcdf file and get it returned as JSON. It's written in Java and runs in Tomcat. And on the right, Argo client is a little web application, the one that I just showed on the screenshot on the slide before. It's written in TypeScript and uses HTML5 canvas and open layers to display the map and plot. Yeah, that's all. It was really short. Thank you very much, and I will show what I did. Okay, here you can see the map and you can see the plot, and you can move the mouse across the plot and see the corresponding profile location highlighted on the map. It's an interactive map. You can pan and zoom it. And you see the locations and the track of the probe. It's going in this eddy thing off the coast of Norway. And there you can see how it moves in circles around the center, more or less. And down there should be buttons which are missing. I don't know why. Probably because of my taskbar. Ah, yeah, okay. And there you can change the view between temperature, dissolved oxygen. Dissolved oxygen looks weird. I have tried another data set which also looked weird, so I guess either there is something wrong with how I read the file, or there's something wrong with the data. It shouldn't look like this, because these are only extreme values and it just doesn't look realistic to me, at least. Salinity looks fine, and you can also see how it correlates with temperature. It's a very similar pattern. Yeah, and that's how you can explore the data. You can see that there are some spots where the surface temperature is quite high. And that's all the program can do. There are many things that could be improved. For example, right now the netcdf file that is read is still hard-coded. It would, of course, be nice to have a list or even be able to provide a URL so that you could read any netcdf file that is available somewhere on the web. this is no problem from a technical point of view. I just had no time to implement it. Yeah. Any questions? Yeah.
Up at the top, you got these things that look like the folds in the Northern Lights, for example. Is that seasonal variability, or what kind of a timeline is this on?
I don't know. I didn't.
These profiles are roughly 10 days apart, so the temperature at surface can probably be explained by it being summer.
Could it also be that it just turned around the circle every time it's in the south part of the circle?
Yeah, it's not the same area. It's different.
Is it always the same area?
No. This one is here, this one is here.
That shows why that's cool.
And this one is here.
You can ask a question. That's cool. You can ask a question like, is it area or is it season?
Yeah.
And you can really quickly get the answer, no, it's a different area.
Argo is very difficult to look at for kind of these reasons in that you're kind of moving in both space and time.
Yeah.
So it's hard to figure out what is a result of where you move to or what is a result of a change in time. But being able to visualize it like this is really good. And I think we spoke a little bit about things you could do next, about adding in some of the satellite surface imagery there. Because then you've got a different perspective on what is actually going on at the top of that graph too. I think we could do that with the...
Yeah, one question that I asked myself was, do scientists even look at such a single file with data from just one probe? It doesn't make so much sense to me. I guess the real benefit of the whole thing is to have all the data from all the probes so that you get more or less complete coverage.
Yeah, they use it in several ways. They do use it to create sort of like big climatologies and big maps. They're also, the nice thing about the Argos is that you can connect the surface features like at quite high resolution to stuff that's going on at depth. So those eddies and stuff that you picked up in the message in bottle application, you can actually see those in the satellite pitch, but then you can often look down through them as an Argo global profile through them. So it's a really good way of visually connecting that data. So for individual probes, yeah, you might look at a feature like that.
Any more questions? Okay, thanks.